China just unveiled their Starship Copy. Stainless steel body? Check. Aerodynamic flaps? Check. Full reusability promised? Check. But look closer at this image. See that smooth, bare metal on the upper stage? That's the fatal flaw. No heat shield, zero thermal protection. SpaceX spent years in 18,000 tiles to survive re-entry at 1,650 degrees Celsius. This Chinese rocket? Exposed steel facing plasma temperatures that melt metal in under 2 minutes. Here's what doesn't add up. How does bare stainless steel survive temperatures that vaporize spacecraft? According to reports from China.com, this Starship lookalike was developed by Beijing leading Rocket Technology, a startup that originally called their vehicle Xinghao 1. Recently, though, they rebranded it to something far more direct, Starship 1. Not inspired by Starship, not similar to Starship, just straight up Starship 1. That tells you everything about their strategy right there. The rocket follows a two-stage configuration, with the first stage clearly modeled after SpaceX's Super Heavy booster. The upper stage continues this pattern, smooth bullet-like shape, forward and aft aerodynamic flaps, the whole package. From a distance, if you squint, it could pass for the real thing. They've copied the exterior proportions with impressive accuracy. They've replicated the general layout. They've even mimicked the landing profile in their official diagrams. But when you examine the technical specifications they've released, 3 critical differences immediately stand out. First, there's no visible interstage ring between the 2 stages. Second, there's no indication they're using hot staging, the technique where the upper stage engines ignite before separation. And third, most critically, the upper stage shows absolutely no evidence of a heat shield, no tiles, no thermal protection blanket, no ablative coating, nothing but bare stainless steel facing the void. Now here's where this gets really interesting. In Beijing, leading Rocket Technology's own operational diagram, which they released to explain how their rocket works, they literally used an image of SpaceX's Starship sitting on the launch tower to represent their full-stack configuration. They didn't even bother creating their own render for that part. They just took SpaceX's hardware and slapped their mission profile around it. The lack of shame is almost impressive. According to their diagram, the rocket launches as a complete system, separates the stages mid-flight, then both stages return for recovery. The booster performs a flip maneuver and lands on a drone ship. The upper stage continues to orbit, deploys its payload through what they describe as a door-like section, instead of a traditional fairing, then closes that door and re-enters the atmosphere for its own drone ship landing. Everything about this sounds plausible until you remember one small detail. Re-entry from orbital velocity generates temperatures that would turn their unprotected stainless steel into molten slag before the rocket even reaches the lower atmosphere. So, what's their plan exactly? Let's talk about the physics problem they're pretending doesn't exist. When a spacecraft returns from orbit, it's traveling at roughly 17,500 miles per hour, about 25 times the speed of sound. At that velocity, you're not just moving fast, you're carrying an enormous amount of kinetic energy that needs to go somewhere. As the vehicle hits the atmosphere, that energy converts directly into heat through friction and compression of the air molecules in front of the spacecraft. The temperatures generated during this process aren't academic. We're talking about 1,650 degrees Celsius at minimum, often much higher depending on the entry angle and vehicle design. For reference, stainless steel begins to lose structural integrity around 800 degrees Celsius and starts melting around 1,400 degrees. The plasma sheath that forms around a re-entering spacecraft exceeds both of those thresholds easily. This isn't a theoretical concern. It's fundamental thermodynamics. SpaceX understood this from day one with Starship. That's why they developed an entire thermal protection system consisting of approximately 18,000 hexagonal heat tiles. Each tile is made from a silica-based material designed to absorb and dissipate heat while protecting the steel structure underneath. The tiles aren't decorative. They're not there for aerodynamics. They exist because without them, Starship would cease to exist as a functional vehicle within the first 30 seconds of reentry. And developing those tiles wasn't quick or cheap. SpaceX started working on Starship's heat shield around 2019. They tested early tile concepts on Starhopper. They refined attachment mechanisms through 2020 and 2021. When they finally attempted orbital re-entry tests starting in 2023, they lost tiles, discovered weak points, and had to redesign sections of the system multiple times. Even now, after years of iteration and hundreds of millions of dollars invested, they're still improving tile reliability and coverage patterns. The IFT-6 mission in November 2024 showed better performance than previous flights, but SpaceX engineers openly discuss ongoing work to enhance thermal protection margins. So when Beijing leading rocket technology shows us renders of a rocket with zero thermal protection and claims it'll achieve full reusability with ocean landings by 2027, what exactly are we supposed to think? Either they've solved a materials science problem that stumped SpaceX for half a decade, or they fundamentally misunderstand the challenge they're facing. The Columbia disaster in 2003 serves as a grim reminder of what happens when thermal protection fails. A single damaged tile, just one compromised section of heat shield, led to catastrophic structural failure during re-entry. The vehicle broke apart and 7 astronauts lost their lives. That wasn't a rocket with no heat shield. That was a spacecraft with decades of proven thermal protection technology that suffered one localized failure point. Now we're looking at a Chinese startup proposing to skip thermal protection entirely and somehow expecting a different outcome. The math doesn't work, the physics doesn't work, and the timeline they've proposed makes the situation even more absurd. But let's say, for the sake of argument, that Beijing leading rocket technology has some secret thermal protection breakthrough they haven't announced yet. That still leaves multiple other engineering problems that their current design completely ignores. Problem number 2. Their operational diagram shows both stages landing on drone ships. Fine, lots of rockets land on drone ships. But here's the catch. Their rocket doesn't appear to have landing legs, none visible in any of the renders or diagrams they've released. So, how exactly does the vehicle remain stable once it touches down on a moving platform at sea? SpaceX's Falcon 9 uses 4 deployable landing legs that provide a stable base. Even with those legs, Falcon 9 has occasionally tipped over during rough ocean landings. Beijing, leading rocket technology's solution? Apparently they're counting on what they call an intelligent grid recovery system. According to their marketing materials, this system is supposed to replace traditional landing legs entirely. They claim it will simplify vehicle design, reduce mass and manufacturing costs, and enable safer, more flexible recoveries. But they don't explain what this system actually is. How does it work mechanically? What catches the rocket? How is it secured? Where's the test data? They're asking us to accept that they've revolutionized rocket recovery without showing us a single piece of hardware or even a detailed technical diagram. Even SpaceX, with unlimited resources and the best engineers in the industry, hasn't perfected catching with the Mechazilla arms yet. They've achieved it successfully on a few flights, but it required years of development, multiple test campaigns, and enormous infrastructure investment. The tower alone costs tens of millions of dollars. Now, a Chinese startup with $13.9 million in funding claims they'll do something similar, or maybe better, on a moving drone ship in the middle of the ocean. The confidence is admirable. The credibility is non-existent. Problem number 3. Hot staging, or rather the complete absence of it. SpaceX learned during the first integrated Starship flight test that stage separation creates extreme mechanical and thermal stresses. The interaction between the booster's engines shutting down, the upper stage engines igniting, and the structural forces involved caused significant damage. That's why they developed the hot staging ring, a reinforced section that protects the booster during upper stage ignition and allows for a cleaner, more controlled separation. Beijing. Leading rocket. Technology's design doesn't show any equivalent hardware. No hot staging ring, no reinforced interstage structure. Just a clean separation between stages as if it's a simple matter of unbolting two pieces. What happens when the upper stage engines ignite mere meters away from the booster's top? Where does all that exhaust energy go? How do they prevent the kind of damage SpaceX experienced before they implemented their solution? Once again, silence. No technical explanation, no acknowledgement that the problem even exists. These aren't minor details. Each one of these issues alone could doom the entire program. Together, they represent a fundamental misunderstanding of what it takes to build a reusable orbital rocket. Beijing, leading rocket technology, isn't alone in this approach. They're part of a broader trend in China's commercial space sector, where multiple companies are openly copying SpaceX's designs, while claiming they'll achieve similar results on compressed timelines and minimal budgets. Take Beijing Yushi Space Aerospace Technology, founded in 2024. They're developing a rocket called AS-1, stainless steel construction, Methalox propellant, and recovery via robotic arm capture system. Sound familiar? They've explicitly stated they're aligning their technical approach with SpaceX's Starship program. They're not even subtle about it. In mid-2024, they raised approximately $13.9 million to fund development. Their rocket is smaller than Starship, 4.2 meters in diameter compared to Starship's 9 meters, but they claim it'll deliver 15 tons to orbit with reuse capability by the late 2020s. For propulsion, AS-1 uses the Longyun engine, manufactured by Guizhou Cloud Arrow. That engine is itself a direct copy of SpaceX's Raptor 3. The FY-100, as it's officially designated, replicates the Raptor's full-flow staged combustion cycle, its thrust level, and even its physical dimensions. Guizhou Cloud Arrow hasn't hidden this fact. They've presented the FY-100 as a Chinese equivalent to Raptor, suitable for powering Chinese equivalents to Starship. Then there's Cosmolite with their LEAP rocket, which blends design elements from both Starship and Falcon 9. There's Land Space, which evolved from solid fuel rockets to the Methalox-powered Zhuque 2 and is now developing the reusable Zhuque 3, again incorporating SpaceX design philosophies. The pattern repeats across multiple companies: copy the form, promise rapid development, attract investment, skip the hard validation work. Now, to be fair, not all Chinese space companies follow this approach. Landspace, despite incorporating some SpaceX-inspired elements, has actually demonstrated real technical capability. They successfully launched Zhuque 2 to orbit in 2023, the world's first orbital rocket powered by Methalox propellant. That's genuine innovation. That's a company that understands you have to prove your technology works before you promise orbital reusability. But the copycat programs we're discussing here, they're different. They're presenting slide decks and funding rounds as if they're equivalent to flight-tested hardware. They're projecting timelines that ignore everything SpaceX learned through painful, expensive failures. And most critically, they're skipping entire categories of engineering problems, like thermal protection, as if those problems will somehow solve themselves. The question isn't whether China can build advanced rockets. Chinese engineers are absolutely capable of world-class aerospace work. The question is whether these specific companies, with these specific approaches, can succeed when they're fundamentally misunderstanding what made SpaceX successful in the first place. SpaceX didn't succeed because Elon Musk drew a cool-looking rocket on a napkin. They succeeded because they spent 2 decades failing, learning, iterating, and refusing to cut corners on the hard problems. They blew up Falcon 1-3 times before achieving orbit. They crashed countless Falcon 9 boosters before perfecting propulsive landing. They've destroyed multiple Starship prototypes, testing systems that these Chinese startups are claiming they'll perfect on their first attempt. You can copy the shape of Starship. You can copy the materials. You can even copy the engine design if you have detailed enough intelligence. But you cannot copy the experience that comes from methodical, painful learning. You cannot shortcut the physics. And you absolutely cannot skip thermal protection and expect your rocket to survive re-entry. The coming years will reveal whether this copycat strategy produces results or just expensive failures. But based on what we're seeing right now, the missing heat shields, the vague technical explanations, the impossible timelines, the outcome looks painfully predictable. These programs are building rockets designed to fail, and the only question is whether they'll recognize that fact before or after they attempt their first launch. Here's what it comes down to. You can copy Starship's exterior perfectly. You can replicate the flaps and the stainless steel construction, but you cannot copy your way past thermodynamics. Those 18,000 heat tiles on SpaceX's Starship aren't decorative. They exist because physics demanded them. Beijing, leading rocket technology, is showing us bare metal and claiming it'll survive 1,650-degree re-entry temperatures. That's not innovation. That's ignoring fundamental engineering reality. SpaceX spent years and hundreds of millions developing thermal protection because they had no choice. The Columbia disaster proved what happens when heat shields fail. Now, Chinese startups are acting like that lesson doesn't apply to them. What concerns me most is the wasted potential. China has real aerospace talent. Landspace proved that with Zhuque 2. But these copycat programs are burning resources on rockets designed to fail because they're skipping the hard problems that cannot be skipped. When 2027 comes and these vehicles attempt re-entry, we'll get our answer. Either they've discovered physics SpaceX missed, or they'll learn why thermal protection isn't optional. My money's on physics. What's your take? Yes or no in the comments, and subscribe to New Space Review to follow how this story unfolds. Because when ambition meets reality, the results are always revealing.